yeah, why do the atoms react to form bonds? See, in fact, we will have a question. See, like there are many atoms. If you happen to see the periodic table, there are hydrogen, helium, neon, and chlorine, phosphorus. There are metals, non-metals, metalloids. There are multiple number of atoms. Why do these atoms react to form bond? Why do these atoms react to form compounds? See, for instance, if you happen to take a glass jar, so okay, you can take a glass jar. So this is a glass jar, and you know, so let this be the chlorine gas. Okay, chlorine, it is a greenish yellow gas. Okay, and you just burn some amount of sodium, and if you put that sodium, that burned sodium, if you put it into this glass jar, it will intensively some bright light forms, and if you happen to see the surface, you will see that like some powdery substance it will be sticking on this surface, and if you scratch it using some spatula, and you can take it out, and you will see that, so this it contains sodium chloride. Okay, so this is actually chlorine gas, and you put sodium metal. Okay, and sodium, it reacts with the chlorine and it forms the sodium chloride. Sodium chloride is a white, nothing but the table salt. It is a white crystalline substance. So if I write the reaction, it will be Na plus Cl2, it forms NaCl. Okay, so this is actually white crystalline solid. Okay, and we will have a tendency like why, now we can ask why the sodium, it is not existing itself, why it want to react with the chlorine, why chlorine gas, it is not existing itself, why chlorine gas want to react, and why there is a tendency to form the sodium chloride, the compound sodium chloride. This question will come to our mind. Yeah, this question, that means why do the atoms react to form react each other to form bond? We can answer this question by looking into zeroth group elements. See, zeroth group elements, helium, neon. What are the zeroth group elements? Helium, neon, argon, xenon, krypton. Okay, so these are the zeroth group elements. These elements doesn't react each other. See, now why these elements, why when all other elements are reacting, why these elements alone not reacting each other, why it does not want to react each other? So we can look into that, its electronic configuration. Neon, it is 10, so it is 10 is the electronic configuration, atomic number, so it is 2 8. Okay, and yeah, argon, if I check it, it is 2 8 8. This is the electronic configuration for argon. So you can see in outermost shell of helium, if you check it, helium, it is having 2 electrons. Okay, and see, if I draw its shell, yeah, let this be the helium, and see here, it is having 2 electrons, only one shell completely filled, and if I check a neon, that is also completely filled, because L shell, it can accommodate maximum 8 number of electrons, and you can see actually either it should have either it will be, if I check a helium, neon, argon, krypton also, it is going to have 8 electrons in the outermost shell. So what I can understand from that is the elements which got 8 electrons in the outermost shell, or 2 electrons if it is having only one shell, will not react at all, because it is already saturated. It doesn't want to have one more electron, it doesn't want to lose the electron also. So the reactivity is, or what makes an element reactive is, or like unreactive is, okay, what makes an element reactive is, it want to acquire 8 electrons. It want to acquire 8 electrons in the outermost shell. Once that 8 electrons are completed, that means it doesn't react at all. It is not going to react each other. Okay, and So this way of arrangement we call it as a stable electronic configuration. Stable electronic configuration. Okay, so once 8 electrons are attained, you know, this is actually stable electronic configuration. Once the stable electronic configuration is attained, that element will not react. For instance, you know, neon, it is actually the unreactive gas used in the light tubes for advertisement. See, suppose some food bottles, food cans, or like some welding material. Suppose, you know, okay, let it be food material itself. Okay, so if you are filling, so okay, so this is food or some food items, let it be. So if you are filling argon or like a helium, okay, so this food, it will remain without decaying, because so you know the food has to react with the oxygen in order to spoil the food. But if you are filling argon and if you are filling helium, what is the peculiarity is these elements will remain on the space, and it will not make this food materials to react each other. And you know that food cans, it is it is protected from, you know, pathogens and microorganisms and all. Okay, so this is the case with the you know, like food cans which is filled with the helium and argon, and it prevents the attack of other substances and all, right? Yeah, let's see this mystery in which how the electrons are attaining, how the atoms are attaining its outermost electrons. So let's see the mystery and how it is gaining the electrons, and how it is attaining the 8 number of electrons. So 8 electrons in the outermost shell. See, for example, sodium it got an atomic number 11. So it will have an electronic configuration 2 in the K shell. L shell, it is having 8, and EKL it is having 1 electrons. Chlorine, it is having 17 is the atomic number 17. So it will have 2, 8 and 7. So easily the, you know, when sodium and the chlorine is reacting, so it will form sodium chloride, right? So you can easily write for sodium to have 8 electrons in the outermost shell. It can easily do one thing. It can just throw away this 1 electron to chlorine. Okay, that means this 1 electron it can throw away to chlorine. Okay. Now what will happen is the sodium, when it is losing 1 electron, its electronic configuration it changes to 2, 8. Okay, it changes to 2, 8. Chlorine, its electronic configuration, see, if it is accepting this 1 electron, it will changes to 2, 8, 8. From where this 8 is coming? 7 plus 1. See, 7 plus 1 this electron. Now you can say, see, what is the charge of electron? Electron is actually, in fact, it is negatively charged, right? So when sodium is giving one negatively charged particles to chlorine, so it will attain, chlorine is going to attain some negative charge. So it changes to Cl minus. Here, sodium, you take the outermost shell. See, sodium 2, 8, 1. So this electron, here actually 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons. Here actually 1, 2 electrons, right? Okay. And here, you know, when this is losing 1 electron, okay, when it is losing 1 electron, see here it is already having 11 protons. Since there is 11 electrons, it is in fact, when a neutral sodium atom, 11 protons and 11 electrons, right? So it is going to have a 0 charge, right? Now when it is losing 1 electron, it is ultimately going to have, so the proton number it will not change, 11 positive charge it will remain there, and now when 1 electron is losing, it will become 10 electron ultimately. So the charge is going to be 1 positive charge, it is going to remain with the sodium. So the sodium, it exists as Na positive. right? And on the other hand, for chlorine, yeah, chlorine it is having, see, yeah, I will draw here. So 2, 8, 7. 1, 2, 3, 4, 5, 6, 7, 7. Yeah. Second one, KL shell, 1, 2, 3, 4, 5, 6, 7, 8. So here K shell, it is 2 electrons, right? Now here it is very clear for chlorine. It is 17 positive charges and 17 negative charges. So ultimately 0. When it is accepting 1 electron from sodium, okay, 1 electron it is going to sodium. Sorry, chlorine. When it 1 electron from sodium, it is going to chlorine. Here this extra electron it is coming here. Now this has changing to 17 protons and 18 electrons, right? So one charge it is going to be excess, so the chlorine it is going to attain Cl minus charge. Here one thing you have to know, now the electronic configuration of sodium it is 2, 8. For Cl minus it is 2, 8, 8. Now you know sodium is happy because it got 8 electrons in the outermost shell. Chlorine is also happy because it also got 8 electrons in the outermost shell. Chlorine is also happy because it got 8 electrons in the outermost shell. Both are stable, both now doesn't want to react each other. And here one more thing you need to know, that Na plus is bind with Cl minus, because this positively charged ion and negatively charged ions due to electrostatic opposite charge it react each other, it attract each other. So the sodium and chlorine, you know, NaCl it remains like this, you know, the bond it will be strong. Okay, now let's see what is the meaning of ions. See, an ion what you need to know is, see, what is an ion? See, Cl minus is an ion, Na plus is an ion, Ca2 plus is an ion, and Mg2 plus, that is also an ion. Maybe you can say PO4 3 minus. These are complex ions. Of course, you will come to know in future classes. These are ions. What is meant by an ion? Any charged species, you can say it is an ion. When it is not having equal number of protons and neutrons, when it is having protons and electrons, sorry, not neutrons, protons and electrons in the equal number, that is going to be neutral. So this is an ion because it is having negative charge. This is also an ion. It is having positive charge. This is also an ion because it is having a positive charge. PO4 3 minus, that is also an ion. Okay. So when the same number of protons and electrons are not there in an atom, that is going to be an ion. Right?